Okie dokie, day 6. So I've done a little bit of pre-reading, and this looks a little bit linked listy. We might end up running to ownership problems here. I hope we don't, and the way I think we're going to do it, we won't. So, we have a set of inputs which are orbits. So there's a common centre, B orbits the common centre, G orbits B, H orbits G. C also orbits B, D orbits C, so on and so forth. That's just setting this up is what we're going to start with. Now, this is essentially a tree with a bunch of nodes. I've done a bit of work to create some tests. This test does not yet work. The sample data that they've given us for the answer to part 1, which is how many total orbits are there, direct and indirect. So B orbiting com is 1, G orbits B and also com. That's an extra 2, so on and so forth. It's 42. The answer to life, the universe, and everything. I have no doubt that was on purpose. So, first off, I think we need a struct called an orbit node. An orbit node is going to have an ID, which is a string that it owns, and children, which is going to be an option vec orbit node. So far, so good, and let's derive debug, and I don't think we'll need comparisons, but cool. So then we have a function called build nodes, which is going to take a string, and it's going to return an orbit node. Specifically, it's going to return the head node, which will own all children nodes. Now, it looks like, from this diagram, any given node can only have one parent. So going from left to right, com will own B. That's fine, there will only be one copy of B, no references. B will own G and C, G will own H, so on and so forth. Part 2. Inevitably, there are going to be some circular references, I think, or just weird stuff. So, our input string will look like the right. It is just a raw string. So, orbits is input string lines. Lines is going to give us an iterator. So, for each orbit, so the first one, to construct this, assuming that this input comes in order, this is not a problem. But if it's not, in fact, let's impl this. From string. Impl orbit node. Find child node. Going to take a ref self, an ID, which is ref sure, and it's going to return. Is it going to return a reference to an orbit node, or it's going to return a mutable reference to an orbit node, I think. And to do this, okay, so first off, if that is true, then return sum and self. This is not fine, this is get child node. Return a reference to ourself. I think the borrow checker might be very unhappy here. Okay, no, fine. Then if that's not true, let's iterate through the children. So for child and children, if child ID is equal to ID, return some child, and child is a ref mute orbit node, so that's fine. Else child dot so this can't be an early return. So else if so let's do this without any ultra super duper rough syntax. If let some node is equal to child dot what's this called? Get child node ID return node. Just return instantly, and we're going to pass this mute ref node up and up and up and up. And up. Don't need those semicolons. This one looks unhappy. The first child we find is the one that's going to come back, and this is going to be a depth first search. If none of those are true, then we're just going to return none. Hopefully that is fine. There's probably a more elegant way to do it, but for now, that's fine. So, let mute head equal to be an orbit node. And actually I need the ID first. So let ID child be equal to orbit next unwrap split on that, and is there a function called collect tuple? I don't think I need to do a stir.trim, so let's just go ahead. Collect tuple a thing? No, collect tuple is not a thing. Collect into a tuple of string and string. Pattern is refster, so actually I need to map this to owned, and then collect it into a tuple of string. And my brackets are wrong. No, my brackets were right. Right, what don't you like? Yes, we don't know that there are only going to be 2 items. Let's just do this over more lines then. Let mute parts split on that to own, so we have an iterator over own strings. Let ID is parts next unwrap. Let next is parts next unwrap. So mute head is going to be an orbit node where ID is just ID, and next must exist let child be equal to an orbit node. ID is next, and children is none. This is probably going to be horrendous. Children is going to be some back child. So we have a head node. You know what I think? I think input string actually needs to be... we need to return head. Okay, so this doesn't currently work, but... and head does not need to be mutable. What don't you like about that? Mute. What if this were in fact a type called iter? Can I just directly... So input string.lines is going to give... Oh, you're unhappy, because... Come on. It gives me an iterator that's just called Corstra lines. Can I do that? And then... Let me just make that mu orbits. Does that work? So it is possible to make this recursive, and we're just stripping off the first thing each time. So what do you need? You need the head, don't you? So head is an option orbit node. Match head, none. And I want to do all of this. So we're going to take the ID, we're going to take the next child. That should probably be called child. Child ID. And then we give it that. So then some mute head. So now we've got to the second line. So I think these can move up. Let node, mute node be equal to orbit node with an ID of, so just ID, and children is going to be some vec child ID. So far so good. What don't you like about that? Expect an orbit node. You can also go up. So we definitely have a node string, so there's definitely a child. So we create a node, and what we need to do is we need to add any children to this node, which means we don't actually need to find stuff. So then what I want to do is I want to do node from string, then current orbit. No, you can't do current orbits because you might end up branching off, and then that branch is going to be added on. So we do need the get. So I need to know if ID exists in head. This can't be recursive then, because I always need to be at the head, follow it down, find the ID, and insert. So what I need to do is get child node. I want my impl block. Thank you very much. Fun. Insert child. Take a ref mute self and a node. And it's just going to be self, children, push, child. Self. Yeah. All nodes guaranteed to have a child. No, they're not. If let's some children is ref mute self children, children push child, else self dot children is sum back child. Yeah, sweet. This has side effects. That's fine. So from string we must start on head, so we don't need to match on head anymore. We don't need that to be lines anymore, that can be a string. Doesn't need to be mutable. And input let mute orbits is input lines. Okay. So we create the first one. You just go there. Get rid of that. So I think now it's a case of, well, let's sum orbits. We do this whole thing again. Split, map to owned, ID, child ID, yes. So then we create a child orbit node which has no children of its own. And we say self dot, nope, not self, head dot get child node on child ID. ID is a ref step, so I'm going to use child.id. I'm going to use refchild.id. Yes, this should work. And then we need to do if let sum that. Then found. So we're going to create our child node, and we know it needs to exist somewhere. Really, this if let sum, this should always be true. But what we're going to get is a ref mute orbit node, so it's going to be found dot insert child on child. It's completely owned. Child is now no longer valid for use after here because we've given child to whatever node we found. We then drop the reference to found and we come back to our head. What do we do otherwise? Otherwise we panic. Panic. Oh, stupid keyboard. Owning node not found for child.id. Yeah, you are just I. Oh, hello, I fucked this up a little bit. So, child ID. So what we've got a string, we've got B or C, and we split it. So I'm now saying that the node I'm looking for, okay, yeah, this was child ID. So what I'm saying is, I am looking for B, and I'm going to insert a child called C, which has no children itself. So get child node is just going to be ref ID. So we're going to look for this ID, which will be, say, node B, and we're going to give it a child called C, which itself has no children yet. Then we move on to the next line, we'll look for B again, we'll give it another child called D, that also has no children, then we'll look for a child, then we'll look for a node called D, and that shouldn't ever happen, because this input should be well formatted. This could happen if we get given, this is why the input has to be in order. Well, ideally this is why the input has to be in order. If it's not, that would be a massive problem. Because, you know, if we had, say, that, we'll set up our common center, which is our head. It has a child of B. And then we say, well, we're going to set up also this object D, which has E orbiting it. But we don't know where D is. We don't know where D is supposed to live, who owns D, where does it orbit. And so you could just say, well, I'm a sort of a floating orbit thing. But for an input the size we've got, if you've got stuff out of order, you'd need to just continually go through and just find, where's the next one I can put it up, right? Yeah, there, okay. And I don't fancy that. I don't think it's going to be the case. If it is, we will panic. And then we return head once we've run out of strings. So, why are you unhappy? Build nodes is actually orbit node from string. We do nothing with test data, that's fine. Orbit node from string and orbit node from string. So now I know that I have let node E is going to be an orbit node with ID of E to string, children none. Let node D is orbit node D to string, and children is going to be some vec node E, owned, not a reference. Let node C be an orbit node with no children. Let node B be an orbit node, and the children is going to be node. And let's go through this in the right order. Node C and then node D. And then let node com be an orbit node, com to string, children some vec node B. Sweet. And this is why I need to have derived partial eq assert eq test data and node com. Whoop. And there's the alarm. So it's possible all we've managed to do is hopefully build a system that does not compile. Where are you? You are somewhere in here. Expected ref mute option node, found ref mute orbit node. Return node on get child node. Okay, that's that one then. I can just return this directly. Because if it's none, then it will be none. No, I can't return it directly. This is why, yeah, okay. So I have to check it, because if I don't check it, then I'll do a very early return. This is a depth first search. If I get to the end and say, well, it's not in this line, return none, it could be in another line. So I need to return some node. If I found the node, otherwise we return none. Okay. Okay, one test passed, which was building the map. Great. Whew. This is one of the things people do. Some crazy sort of like very short lines. I find it very hard to reason about if you can't do stuff like this. Just helper functions everywhere. Right, well, that was day 6, part 1 of hopefully, I mean, not very many. Finishing part 1 now should be pretty trivial. We just need a function that traverses the head node and says, well, how many orbits do we have? That is going to be recursive. But that's for next time.